only. Okay, so the answers were also provided for this, so you should have been able to check your answers. Now, question 1. Part A, part 1. Cross-section of the solid machine part. Cross-section being this region. Okay, so this region is clearly the area of a trapezium. Area of trapezium, you need to know the formula. You need to memorize it. It's not provided for you. Minus away the area of that semicircle. So nothing complicated about that. You just need to identify what the radius is for the semicircle, or if you're using pi d for area of circle, then that's not an issue also. So just put in the missing dimension over here. This will be our radius 3 cm, meaning 6 cm for the diameter. Okay, with that, we have all the dimensions required for semicircle as well as the trapezium. Then next, the volume of the solid machine part. So volume of this, once you have the cross-sectional area, very simple. All you need to do is to just multiply by its perpendicular height. Okay, so in this case, the cross-sectional area, 52 minus 9/2 pi, as expected, it is a number minus away the area of the semicircle. So it is in terms of pi. I do not want to use 37.9. It is 3SF, not good. So the volume will be, I would rather use my 52 minus 4.5 pi multiplied by 28. 28 is our perpendicular distance. So every time we are doing volume of prisms, you need to visualize in your own mind that we are taking this yellow portion, we multiply through this distance of 28 cm. It is like we are stacking many of them. Imagine post-it looking at this shape. You have one piece, you stack until 28. So the volume is given by area of the highlighted portion multiplied by the thickness. So we get the volume. Next, we have to calculate the surface area of the solid machine part. So surface area is a little more complicated than volume, but it's not difficult also. All we need to do is to multiply 2 of this yellow portion. The front and back, they are the same. So we have 2 of them. Over here, 2 times of 37.863. This is the 2 yellow highlighted portion. Plus 1. We need the lateral faces, meaning everything else that is not the cross-sectional area. So the yellow portions are the same. In addition to these 2, we need the surface areas of everything else that we can touch. Okay, how do we find that? We simply take the perimeter, and this is the easiest way. Take the perimeter. So I'm going to outline the perimeter in green. Perimeter of the cross-sectional area. Okay, the green color portion. Now, if you have the distance for the green color outline, okay, imagine it is like a wire thread, a piece of wire that is bent into the green color shape outline. You stack many of them together. Many of this green color wire in this shape, follow, you stack all of them together, you're going to end up with all these portions, everything else that is green. All this will be in green. All the curve, all this at the other side, and at the bottom as well. All of them will be encompassed by stacking of the green color wireframe. In summary, all the other areas, except the yellow ones, is found simply by taking perimeter of cross-section, okay, perimeter of that yellow shaded region, multiplied by 28. So every time you're doing this type of question, you visualize this is what is happening. Very little memorizing involved, and you will understand why it is like that. Now, if you find the method complicated, the perimeter multiplied by 28, it's very difficult for you to understand. I've got another solution for you, but it also involves visualizing. You need to be able to unwrap Imagine you're wrapping this as a present. You need to unwrap this present. You make a cut anywhere over here. Say you cut over here. You unwrap it. You're going to end up with a rectangular piece of paper. Okay, this distance will be 28 cm. Then we've got our 2 cm over here. The same 2 cm. Followed by the distance in your semicircle, followed by another 2 cm, followed by a 5 cm, followed by 16 cm. Oops, I drew my rectangle too short. 16 cm, followed by another 5 cm. So obviously not to scale up. So you unwrap everything, right? You get a rectangle anyway. And this area of this rectangle, green color one, length and breadth. Where did the length come from? The length came from the outline. Where did the breadth come from? The breadth come from the 28. So it's the same thing. Okay, explain in 2 different ways. Then if you think, well, I really cannot, I don't understand. Okay, then you do it part by part already. 5 times 28, you get 1 rectangle. Plus 16 times 28, you get another rectangle. Plus another 5 times 28, you get another rectangle. Plus rectangle at the top, then you're stuck when it comes to this curve. Then you still need to visualize, and you open it up, become rectangle again. Okay? So then the total surface area is 1180 square centimeters to 3 SF. So this is our revision for this topic. Definitely tested. Okay, next one, question 2 is what we really want to focus more on because it involves our, I believe in Pythagoras theorem in this case. Okay, so there's a pyramid. It's a rectangular pyramid because the base is 10 by 5 cm. Okay, then he paid $360 for it. So calculate the amount of Sing dollars that he paid. Okay, that one we will not dwell too much on it. $504. Now rectangular base 10 and 5. So we know that this is also 5 cm. This will be our 10 cm. The thing about rectangular pyramid is that you have to draw this in a diagram. Okay, draw it now if you haven't drawn it yet. We need to draw that because it helps us form a right angle triangle. Whether it is a square pyramid, rectangular pyramid, a cone even. Drawing the line that cuts through the center of the pyramid is going to be useful. Okay, once you've drawn that, you can see that the base rectangle is divided into 4 congruent rectangles. Exactly the same. And we know the dimensions of all these rectangles because they're just going to be half of the respective lengths on all sides. So let me use blue. Let's talk about this distance. This will be 5 cm. Okay, likewise, this will be 5 cm. And clearly, this will be 5 cm. At the end, also 5 cm. Okay, but I don't want to clutter it too much. So I'm going to only keep what I feel is relevant. Or rather, what is critical for this question. I'm going to keep that middle 5 cm. Likewise, we can also find out what the distances over here are. This will be 2.5 cm. And this will also be 2.5 cm. Whether or not that is also not sure yet. Okay. Now, what else did they say? There is a slant. Where's the ACM? The vertex V is 8 cm vertically above the center of the base. Now, when we drew the 2 green lines that were intersecting each other, they intersect at the middle. So from the middle, vertically upwards to the vertex V, that is 8 cm. Now, can you see right angle triangle being formed? Based on the lines that we just drew. The blue line, the vertical 8 cm, as well as what they wanted us to find, which is Oh, not yet. Okay, I went a bit too fast. The first part was just to find the volume, so we didn't need to know all the information yet. But anyway, I was trying to get to this portion. This line, the midpoint of BC, we call it M. Midpoint, M for midpoint. We can actually form a right angle triangle, and this will definitely be useful later on. So extract the triangle because it's going to be too cluttered. Call it O for the center, midpoint M, and we know that this has the distance of 5 cm, 8 cm. Later on, I'm sure we'll need to find this slant height. Okay, we keep that for later. I think that one will be a few parts down the question. The first portion was just simply to find the volume, which can be easily done using the formula. 1/3 base area times height. Formula not given to you, must memorize. So volume 1/3 base area. Base area is just a rectangle, so 10 times 5. Perpendicular height 8 cm. So you get 133 and 1/3 square cubic centimeters. Take note that you do not need to round this off because it is exact. No rounding off. The next is to find the total surface area. Okay, so here is where we need the area of all the 4 triangles. And then we know that area for a triangle is half times base times height. So taking this triangle as a start, to find this area, I need the base, which is given 5 cm. Simple. I need the height. Now the height is not given, it is the slant height, which is this VM, which we can easily do and find out by Pythagoras theorem. This is simply square root of 8 square plus 5 square. So 64 plus 25. So this is square root 89. That is the area for one of these triangles. And we know that by symmetry, on the other side, it is the same triangle. These two are the same. Because this is a rectangular pyramid. It's symmetrical. So the area of VBC, which is the triangle that we just created, half base height. You can choose not to evaluate this. You can leave it like this first. 5/2 root 89. And then you do so for the other 2 remaining triangles. You will find that when you add everything up, the total area to 3SF is 181 square centimeters. Okay, we've done similar question in our notes. So similar questions, if you keep doing it, it means that it is important. There's a concept you need to know. The concept is to be able to draw the lines at the bottom and to form right angle triangle. In Sec 2, very important, form right angle triangle, 2 things, Pythagoras, trigonometry. So then the remaining one is the slant height BC. To find out this distance in using blue again, VC. And knowing that this green color line has a value of square root 89, we can form another right angle triangle. So this portion, VM, is square root 89. Then our black color base to C 2.5, and the remaining line blue color VC. Easily found using Pythagoras again. So by keeping the VM as square root 89, we are able to achieve a more accurate answer for VC, because VC is going to be square root of 2.5 square plus the vertical length, and we square it. So when you have square root 89 and then you square it again, you're going to be ending up square rooting an exact figure, 2.5 square. So this is 6.25 plus 89. and round off. Okay, this very nice integer 89. I managed to get it because I did not evaluate my square root 89. So if you had left this as a 5SF in your intermediate step without writing square root 89, you would have written 5SF over here. Then you square it. You wouldn't get 89. You will get a long string of numbers, which is not as good. That was question 2. Now question 3. Question 3, we've got a container made by extracting a circular cone of base diameter 12 cm from a solid hemisphere. So this, as shown in the diagram, 12 cm. Then the keyword hemisphere, half a sphere. So when you see hemisphere, you must think of all the formula already. Since it is half a sphere, volume 4/3 pi r cubed. This is for a sphere. So for a hemisphere, we need to halve it. And then the next one, where we have surface area of a sphere. Surface area of sphere. Even though the formula is given 4 pi r square, when it comes to hemisphere, this one is given. When it comes to hemisphere, for surface area, it is not just half of 4 pi r square, because this is going to give us only the curve. But the hemisphere has a flat surface. So you need to plus pi r square for the top. However, if it is like a bowl where there is no flat surface, and then it's just half of 4 pi r square, then you do have the flat surface. It depends on the question. You need to understand what is happening. So now the volume extracted of the extracted cone is 1/6 of the volume of the hemisphere. This is testing whether you know the form equation. Volume of cone is 1/6 volume of hemisphere. You can literally translate that into a mathematical equation. Volume of cone 1/3 pi r cubed, pi r square. Okay. 1/3 pi r square h. Sorry. Volume of the cone 1/3 base area times the height. Is, the word is our equal. Is equal to 1/6. 1/6. The word of is our multiply. Volume of hemisphere. Hemisphere volume half times 4/3 pi r cubed. So we've got an equation with two unknowns. We've got an unknown r over here, and take note that these two r are different. This is r for the cone, this is r for the hemisphere. Okay, we should make a distinction, because for the cone, the radius is just 6. This has a value of 6. The h is the unknown. For the hemisphere, the r value is 10. So once you do the substitution, you can find the unknown value very easily, h, which is 9 and 7/27, approximately 9.259 centimeters. Now they tell us that the exposed surface area needs to be coated with a layer of zinc to prevent it from rusting. So find total surface area. So as mentioned, area of the curved surface for the hemisphere is half times of 4 pi r square. But there are two other surfaces. First, we've got a ring over here. This ring. Area of ring, not difficult. It's just area of big circle minus area of small circle with the respective radii, which you can see easily by yourself. So not going to talk about that. What this question really wants to test us is if you can find the curved surface of the cone. I can't draw a curved surface. Maybe I can do it this way. The curved surface of the cone. How do we find the curved surface of the cone? Let's take a look at the formula again. curve surface of cone equals to pi RL. Pi RL. Pi is a constant, no problem. R is the radius, easily found, which is 6. And we only have L. What exactly is L again? This L is our slant height. We need to find this slant height, which is not given to us, but it can be done. Again, draw your own right angle triangle. Can you see the very consistent theme? Draw and find your right angle triangle. Once you have that, with the height, what was the height? 9 and 7 over 27. 9 and 7 over 27. With that height, we can find the hypotenuse. Okay, using our Pythagoras theorem again. Substitute in, multiply the three numbers, get curved surface area of cone. Okay, so approximately 1040. 1040 square centimeters. And the next one is C part 1. Let's see part 1. After the cone is filled to the brim, the water is transferred to cylinder radius 3, height 5. So number of such cylinders required to empty all the rainwater from the container. So it's just finding the volume of the cylinder lah. So for a cylinder, we can treat it as a prism also. Volume equals to base area times perpendicular height. So the base area, this will be pi r squared. 10 times 5, you get a volume. So how many of those are required? So pi r squared times the height of 5. One container is just 45 pi. For the cone, it is, so the volume of the cone 111 and 1/9 pi. So just do a division lah. What the handwriting 2 and 38 over 81. So you round up, you get 3. Total cylinders required 3 of them. Don't worry about copying, I'll just upload this online, but you need to be able to decipher what is the handwriting here. Obviously not written by me. So find curved surface area of the cylinder. This one, insulting your intelligence. I don't want to go through it. Next one, question 4. Okay, now we have a semicircle folded to form a right circular cone. So you have to be able to, you need to remember what you did in class, no? We had a sector. Then we folded the two radii together and we obtained a cone. So I believe what we did in class was a sector looking like this. Then you join these two parts up, you get a cone. Where the center over here is now the vertex, the tip of the cone. So this is, the blue color one is one way to form our cone. We can even use smaller sectors, for example, like this. Even this can be used to form a cone. Just join these two together. You will get a very narrow cone, very narrow. Whereas this will be a very wide cone, a narrow cone. And then a semicircle is just a special case of a sector. It is just exactly half a circle. So you still get a cone. Okay, now visualize it. Fold AO, make AO and OB touch each other. When that happens, you get a cone. Okay, now which part of the cone came from, let's say, okay, where did this part come from? The tip, the vertex. It came from O, yeah. Okay, so this is our point O in the diagram that is given to us. This is point O. Now, on our, what about the circumference of this cone? Where did this circumference come from? How was it formed? So visualize again the semicircle. Try and press the two straight edges together, and you form a cone. So my circumference of my base of that cone was formed by this portion. Are you able to visualize that? Who can visualize? Can see in your head? Raise your hand. Can see in your head? Okay, looks like it's majority. If you cannot see in your head, take paper, cut, fold, so that there is one less thing for you to memorize. If you cannot visualize and you don't want to fold paper, then you rely on memorizing already. Now I tell you how to memorize. This arc is the same as our circumference for the base. You want to memorize that? Sure, go ahead. But you better not memorize the wrong thing. Next, where is our AO? In the cone. AO. So join them up. There's AO. It's the slant height. AO. Now slant height, anywhere on the cone is the same slant height, because you can rotate the cone, right? You still get the same cone. So for convenience, I'll just call A over here. Okay. And A actually met with B. They meet each other. So it is the same point, A or B, or maybe call it A and B. A and B are now the same point. Okay, so this radius now became our slant height. And then the arc equals to our circumference. Circumference of base of cone. So this is what happened in all cases where we have our big sector, our small sector, or half a circle. All of the radii over here, they are going to be our slant height for the cone. All of them slant height. All these arc lengths, they're going to be the circumference of your base of your cone that is formed. So this is going to be a tiny circumference. Okay, so you get a very narrow cone. Whereas if you have a very big sector, we have a very big circumference as the base. So it's a very wide cone. Okay, now, what other information do we have? We've got our 12 cm over here. In our cone, it translates to the slant height. This is our 12 cm. And then, since the arc of this semicircle is our circumference of the base of the cone, I can find out the base of the cone, the circumference of the cone, by finding out the arc length over here, which is half a circle. Okay, so let's, that's the analysis of this question. Let's go to the question itself. So find the radius of the base of the cone. Radius of the base of the cone is found here. So here's my base. This is the radius. That is what I want you to find. This radius is clearly different from 6 cm. Very different, huh? I'm not going to test you some. We're going to test you something where the answer is just like what, 12 divided by 2 is 6. It doesn't even make sense in the first place. They are two separate things. So back to basics. Where do we get the circumference from? We got it from the arc of the semicircle, which is simply half of the circumference of this original circle. So what is the circumference of this original circle? It is pi d, or 2 pi r if you like. Since diameter is given over here, I'm going to use pi d. Pi d, which is 6 pi. This distance is 6 pi. It is the same distance as our circumference of the base, 6 pi. So we're trying to find a radius. Let's call the radius r. Equals to r. In other words, 2 pi r equals to 6 pi. Then we can cancel pi and pi. When I say cancel, we are actually dividing by pi. And we can divide by pi because pi is a positive number. It is a non-zero. Divide again, left with 3. So radius is now simply 3. 3 cm. Okay, it is exactly half of the radius of the semicircle in this case, because this is a semicircle. In the case of any other sectors that is given to you, it will not be just half. Okay. So if you were to actually get a correct answer in this case without working, where you just say radius equals to 3 cm, you get 0 marks. There's no method shown. You have not shown me why it has to be 3. So I need to see formation of equations. Show the examiner, show the marker that you know what you're doing. So next, find the curved surface area of the cone. To find the curved surface area of the cone, we need pi RL. Our radius, we already had it from the previous part, L 12 cm, which was obtained from the original diagram. So pi RL. Nobody's corrected my mistake. This is not 12 cm. Yeah, it's 6. Hey, you all know then never say. Let me talk so much. This is actually 6 cm. Because this is 6 cm. Okay, so for those of you who are blindly copying, make sure you know where to make the correction. Okay, so pi RL, 18 pi. Leaving your answer in terms of pi. So you get used to it. In Sec 3, Sec 3, Sec 4, there'll be more instances of you leaving your answers in terms of whatever. Okay, very simple, just leave it in terms of pi. Don't go and evaluate, don't press calculator, can already. Nothing to round off. Okay, now question 5. Cone in the diagram, radius x, height 2x. They don't tell you the radius. They don't tell you the height. But they tell you that they are related. The height is double the radius. What this means is that if the radius is 3, then the height is 6. If the radius is 50, the height is 100. Okay, so there's a relationship. Then it further tells us that the volume is 500 cubic centimeters. Based on this, volume of cone, 1/3 pi r square h. The volume of cone, surely we need the formula for volume of cone. Surely we need it. Just write it down first. Ew, they tell us that it's 500. Okay, very good. This is 500. What else did they say? The radius is x. Okay, in my formula, radius r becomes x. Height, in my formula, it is h. But in the question, it is 2x. It's 2x. So 1/3 pi x squared times 2x is 500. I have formed an equation already. It is one equation with one unknown. Surely you can solve it. So approximately 6.20 to 3SF. So slant height are required to find the surface area, because surface area will be the base area pi r squared times the curved area, which is pi RL. Pi RL is the formula that is given to you. You need to know that L is the slant height, L. So the slant height is found by square root of 4x squared plus x squared, because here we form a right angle triangle again, Pythagoras theorem. The base is just x. The vertical height is 2x. So when you square the 2x, take note, 2x, when you square it, you get 4x squared. Not just 2x squared. So total, we have a square root of 5x squared. You can evaluate at this point over here if you like. So this will be square root 5 times of x squared, 6.2035 squared. You can. But when I was doing this a few years ago, I left everything in terms of x so that I only substitute one time in the last step. It's just a practice of algebra also. If you want to do this, I only substitute one time. And my answer is quite exact because I only substitute in the last part. But if you're not confident, you can substitute at the start already. Is this the last one? Oh, no, not yet. Okay, so as mentioned, no need to copy lah. I'll upload this after this lesson. Okay, last question now. Question 6 is pretty straightforward. So I'll just show you the volume. The volume in terms of, I left it in terms of pi first, so that it is very exact. Okay, we've got volume of a sphere plus volume of a cylinder. Sphere because it's two hemispheres, so add up become a sphere. Okay, then the mass. Did they give the okay. So 1 cubic centimeter of the solid has a mass of 2.3 grams. So what about 21463 over 3 pi cubic centimeters? If you recall, this is actually our density. Remember density in physics? You can be tested in that in mathematics for density also. So we can tell you things like density equals to 2.3 grams per cubic centimeter. And then you are expected to be able to use this to calculate whether it is the mass or the volume, or even to ask you to calculate density, you also can. Okay, so not sure if your physics teacher taught you this, but you can actually use this for your density as well. It's just like your speed, distance, and time. You just need to fill in the relevant blanks. Now, part 2 says that the surface is painted $4.70 per square meter. So calculate the cost of painting a solid. Clearly, you have to find out the total surface area of this solid now. But take note, all the dimensions are in centimeters. So if you were to find the area, your area based on the dimension centimeter, the area is going to be in square centimeters. Then you need to convert to square meters to find out the total cost. So that is what was done in the first step. So all the dimensions used in centimeters. So area in square centimeters. After that, you need to convert to square meters. From square centimeters to square meters. 1 square meter equals to 100 square cm square. So this will be 10,000 square centimeters. So what about 1326 pi square centimeters? To convert it to square meters, we need to divide by 10,000. So 1326 pi over 10,000 square meters. So move for 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. 0.1326 pi square meters. This is the conversion to square meters. Then the cost is simple. Okay, so the test over here is to see whether you realize the units for the area based on the diagram will cause you to end up with square centimeters. Then you need to convert. The alternative, if you do not want to do this division by 10,000, the alternative is straight away convert this 13 to 0.13 meters. This 25 cm is 0.25 meters. You do a calculation, your answer will end up being in square meters. So you don't have to do that division by 10,000. You still get the same answer of 1.96. So this is our